Welcome to HPC News Bytes, a weekly show about important news in the world of supercomputing, AI, and other advanced technologies.
Hi, everyone. Welcome to HPC News Bytes. I'm Doug Black of Inside HPC, and with me is Shaheen Khan of OrionX.net. Friday of last week was October 18th, which can also be expressed as 1018, which is similar to saying 10 to the 18th power. That's a quintillion, or a billion billion. And when you have a computer capable of that many calculations per second, you have an Exascale class supercomputer, hence October 18 is Exascale Day. We have an article on Inside HPC in which it's asserted that the focus of Exascale Day has shifted from getting to exascale to what researchers are doing with exascale systems. And the case histories are starting to come forward.
This was a great, fun, clever thing that Cray did a few years ago. And at that time, exascale used to mean exa 64-bit floating point operations per second, all on one application. The Frontier supercomputer officially achieved that a few years ago, but that is still very hard to do. But AI is where the action is now, and AI metrics are everywhere, and they are much easier to achieve since it can use lower precision, down to 4 bits or even lower nowadays. That has allowed people to talk about Zettascale, 10 to the power of 21, October 21st, I guess. So this episode is really on Zettascale Day, one could say. But as we march towards the end of the month, some of us really look forward to October 23rd, which I call the Avogadro Day, after the Avogadro number, when units of measurement in computing and chemistry can overlap, and we can talk about molarity in computing, which I find intriguing. Now, some interesting news in quantum computing. There were articles about Chinese scientists cracking military-grade encryption with quotes that portrayed it as a real and substantial threat to how encryption is happening today. To net it out, what was described does not do that. It shows how they could do it for a very small key, but the algorithm does not scale to large keys, which is no different than the situation with classical computers today. At the same time, quantum-safe cryptography is marching forward, and the process to have the algorithms and to implement them for the more sensitive information is continuing via NIST, the government organization that drives that project, as well as government orders and industry progress. An algorithm's time and size complexity is really the issue. Some algorithms work for small problems but run out of steam, while others are too costly for small problems and only become interesting and gain speed for very large problems. There's also some news from Europe, and especially the inclusion of quantum computing in exascale projects.
Yes, quantum company IQM announced that the Euro HPC joint undertaking will take delivery on 2 IQM Radiant systems of 54 and 150 qubits over the next 2 years. They will comprise the Euro Q Exa system based on superconducting qubits and advanced entanglement. It will be housed at the Leibniz Supercomputing Center in Germany and integrate with LRZ's supercomputing systems. Now, Shaheen, as you know, I'm a C-SPAN weekend geek, admittedly, but if you've never sampled C-SPAN 2 and 3, I urge everyone to check out their weekend content lineup. For example, yesterday they showed a 1982 video of the great Grace Hopper talking about the future of computing in the Navy. At that point in her career, she was a captain, and the lecture she delivers on the limits of mainframe systems and the future of client-server distributed systems is a tour de force of visionary insight. NVIDIA, as we know, has named 2 of their advanced chips in her honor, and watching her lecture explains why. Hopper retired as a rear admiral, and if there were a computer science hall of fame, she'd be in it.
Yeah, lots of great stories about the great Dr. Hopper, who had a doctorate in math from Yale University in 1934, by the way. She was also a member of the team that reported the first computer bug and did a lot to make that story famous. The bug, of course, was an actual moth that somebody found in the Mark II computer at Harvard. That was on September 9th, 1947, and we've been debugging physically and logically ever since. Let's end with a few notices on events and awards. The annual Q2B, that's Q digit 2 letter B, Silicon Valley Conference on quantum computing is December 10th to 12th in Santa Clara Convention Center. It's organized by QC Ware, and it's always a great program.
And there's less than 2 weeks left to apply for an Innovation Excellence Award to be announced by Hyperion Research at their SC24 Market Update Breakfast. Information on the awards can be found on the HPC User Forum website. All right, that's it for this episode. Thanks so much for being with us.
HPC News Bytes is a production of Orion X in association with Inside HPC. Shaheen Khan and Doug Black host the show. Every episode is featured on InsideHPC.com and posted on OrionX.net. Thank you for listening.